Welcome to Academic Digest class. Today we are going to be treating linear momentum. We have linear momentum, we have angular momentum, but today we're going to be treating linear momentum. Linear momentum is defined as the product of mass and velocity. So which means that if you see somebody running, that person has, what you observe from the movement of that person is not just that the person is walking. What you observe is the momentum. So if the person is slow, you observe that the momentum is less. If the person is fast, you observe that the momentum is high. So it's equals to mass times velocity. So you need to know this. Which means that, let's say for example, a car is moving at 30 meters per second. And this car now has the mass of 50 kg. Then you as a human being, you start to run. You start to run. And you are running at the same 30 meters per second. Now let's say you are a small boy and you have 20 kg mass. So you see that the momentum of this car will be higher than your own. What people will see as you move and what they will see when this car move, it will have more intensity with this one. So you will notice that if you have more mass and more mass, you have more velocity. You have more momentum, even if the velocity is the same. And when you have a large momentum, it means that if you hit something, you will, should I say, feel more impacts. You will feel more impact if your momentum is high. But if your momentum is less, if you hit something, your impact will be less. Anyway, what I'm explaining now is for you to understand what momentum is all about. It's not really what they are going to be asking in this particular course. So for this course, you need to know that there are three things they will be looking out for whenever they want to treat momentum for you. The first one is your ability to get force. The ability for you to get the formula of momentum. I will represent momentum with P to be equals to mv. Then your ability to know that this velocity, if it's not given as just one, it can be v minus u, that is change in velocity. So we can say that momentum is mass times change in velocity. So you need to know this. These are the first two things you need to know. Then the third thing you need to know is your ability to remember that force is equals to ma, and that inside this a we have v over t. Do you see it? So that means that force is equals to mv over t. And what you see right here is called average force. This is the formula for average force. It's very important you note this. So whenever you have mass, product of mass and velocity divided by time, or whenever you have, what you have here is momentum. Whenever you have momentum being divided by time, because what you have here is momentum, you say that is average force. So this is the third thing you need to know. And the fourth thing you need to know is that if I have F equals to mv over t, that this t can cross over and come here, and it will give me ft equals to mv. So the fourth thing I need to know is that this formula, force times time, product of force and time, is what we call impulse. And that impulse, and notice that what is here is momentum. I don't want to put change in momentum. For the fact that something is existing, every state, every quantity always have change in its state most of the time. If you remember thermodynamics, yes, so when we did thermodynamics, we talked about system that can change and the one that doesn't change. So if this is momentum, so you see that Impulse is equals to change in momentum. So these are the 4 things you need to note about this course, momentum. Remember that we've not started doing conservation of momentum when we say that momentum is conserved when collision occurs, where we start doing kinetic or Newton's laws of substitution. So we are focusing on just momentum, linear momentum. And these are the 4 formulas you need to note. So you need to know that if you have Ft, force and time, you can just use it and find impulse. And if you are not giving force and time, you can simply say that impulse is equals to mv minus u. And remember that v minus u, this thing, everything here is the same thing as saying impulse is equals to mass times velocity. So you need to know these formulas. So these are the 4 keys you need to have when solving momentum questions. So, but the minute a question under momentum deviates from just one mass, they tell you 2 bodies hit each other, you know that it's not telling you 2 bodies did this or did that. It's not talking about conservation of momentum. Conservation of momentum. So the key thing to take note of is that linear momentum deals with just one mass. It deals with just a mass. But the minute you now start to do 2 bodies, which is 2 masses, it is no longer just linear momentum. It's now conservation of linear momentum. All right. So let's try to look at questions before us and see how we take it from there. All right. I have here before me an unlucky bystander in Lagos finds himself in the center of a shootout between army and police. A 12.0 gram bullet moving at 120 meters per second strikes him and lodges in his shoulder. Assuming the bullet undergoes deceleration and stops after traveling a distance of 60 meters per second in his shoulder, find the impulse in the shoulder and the average force experienced by him. Now notice that in this question they did not give me time. Anytime you are given a question under momentum or impulse and you are not given time, another principle you need to know, which is the 5th principle I will be giving you now, is that you can now use the kinematics formula, which is v squared equals to u squared plus 2as to find a, because notice in most cases they will give you v, or this one is 0 at initial, then you will have distance. So use it to find a. Assuming a was given, you find s. So once you find it, you now use the second formula, which is v equals to u plus at at this point, and find t. When you now find t, you can be able to go back and remember that ft is equals to mv. Impulse is equals to change in momentum. So when you make force subject of the formula, you divide both sides by t. You'll be able to get average force. So it's important you note this. Anytime time is not given to you in the question of momentum, you go ahead with this. So in this question, we are not given time, but let's try to convert. Let's solve. Okay. So please, your comments are very useful, and your likes matter, and your subscribing matter. I was going through the comments where somebody said, yeah, you are the best, and stuff like that. It gives us the courage to do more. So please subscribe, share, and remember to comment. All right, let's write the parameters we have out. So I have the mass to be 12 gram, and we know that gram to kilogram, we know that 1 kilogram is equals to 1000 grams. So let's say I know 1 kg to be equals to 1000 gram. Then s kilogram is equals to 12 gram. So if you convert, you see that you definitely have to divide this. You now have x times 1000 equals to 12 times 1. So divide both sides by 1000. Are you seeing it? So you see that, and 12 divided by 1000 should be having around 0.012, should be. So 12 divided by 1000, 0.012. I'm correct, but these days I don't know what spiritual thing is it that sometimes you just punch your answer and keep it. When you now start to rewatch the video, you notice that there's something that I missed. So these days I'm trying to be very correct. So the next thing they gave us is velocity. They gave us moving at 120 meter. So the bullet's V. So when they say something is moving, you know that is V. Initial velocity there should be 0. So wait a second. Strikes him and runs into his shoulder. Now, assuming the bullet undergoes deceleration and stops. So if the bullet undergoes deceleration and stop, that's another part of the question, because we've seen full stop. So assuming, so on deceleration, and stops, V will be equals to 0. After traveling a distance of S 6 seconds, and I know that this 1 centimeter is 1 meter is equals to 100 centimeters. So 6 divided by 100. So I should be having 0.06. So I have 0.06 meter. So remember to always convert. So then after traveling this, then they say I should find the impulse. I should find impulse. So impulse and average force is what I'm looking for. So I'm finding impulse and average force. Pay attention to when they ask you average force. Average force means mass times velocity divided by time, not MA. You need to know that. So this is the question. So these are the parameters we have. So they said an unlucky bystander in Lagos finds himself in the center of a shootout between army and police. 12-gram bullets moving with 120 meters per second strikes him and lodges into his shoulder. So to find the impulse there, we'll simply say impulse is equals to mass times velocity, or you say change in momentum. This mass times velocity is change in momentum, and we have I is equals to 0.012 times 120. So 0.012 times 120 should give you impulse to be equals to 1.44 Newton seconds. Remember that impulse is force times time. So Newton seconds. So impulse is also having the same unit as kilogram meter per second. You need to know that since it's equals to change in momentum, which is mass. All right, so we've gotten this. Now looking at what we have here, we have at deceleration. We have at deceleration 0. They said on deceleration. So when it decelerated, we will now have V. So at this point, we can say, remember the principle, we need to find time because they did not give us, and we know that we want to find average. We want to find average force, and we cannot get average force without looking for the time. So we need to get the time. So to get this time, we'll do V square equals to U square plus 2AS. These are the two formulas. So V square here is going to be, on deceleration, is 0. Then yes, wait so okay, it's moving with 120. Let's be sure first of all. Assuming the bullet undergoes deceleration and stops after traveling a distance of 6 centimeters in his shoulder. Okay, at this point it's important we note that on deceleration and stops, this will be 0, equals to U now will now be 120. That's 120 that it went out with, that was the final velocity at the first end. So U now will now be 120 square plus 2 A and S is 6. So let's punch so that we now get 120 times 120. We get 14,400 plus 12A. Okay, I think what we need to consider here is 120 square. Then the initial should be 0. The initial should be 0. So this should be 14,400 equals to, so yes, so divide both sides by 12. Divide both sides by 12. This will cancel this. So the reason why I did it that way is that we are considering the velocity that the bullet left with. And you understand it. So at the point where it stopped moving, we don't really know what is happening there. So we are considering what it started with. And you know that in kinematics, anytime you are given that something moves out with a velocity, it simply means that that velocity moves out with is the final velocity. Why moving out, it has an initial velocity which is 0. So divided by 12, we will get A to be equals to 1,200. So if we get A to be 1,200, to find the time now, we do V using the first law of kinematics. First equation, U plus 18. So we now have 120 equals to 0 plus 1,200 T. So, and yes, so, and you know that this is going to be the same thing as saying 120 equals to 1,200 T. So divide both sides by 1,200. This will cancel. So T will be equals to 120 divided by 1,200. So you get T to be equals to 0.01 seconds. So to now find force, the average force. Remember I told you average force is not MA but mass times velocity all over time. Or you simply say impulse is Ft equals to change in mv. I don't like putting this thing, but you can have it in your mind. So change in momentum. So F, now making F such a formula, we divide both sides by T. So this will cancel this. So that you have F is equals to. Now what did you get for momentum? Momentum, they gave us mass to be 0.012. Then they gave us velocity to be 120 all over time, which is 0.01. So if you do it, you now get 0.012 times 120. So you get F to be equals to 1.44 all over 0.01. So 1.44 divided by 0.01. So force is equals to 144 Newton. And that is my answer. That is my answer. That is the final answer. All right. We'll move to the next part. So if you check it, we've been able to answer the whole question. We've answered, find the magnitude of the impulse due to the collision. And we got the impulse to be 1.44 Newton seconds. Or you say kilogram meter per second. And we got duration of time, the time to be 0.01 seconds. Remember, we first had to convert gram to kilogram. You don't use gram. You don't use gram. You don't use gram in physics. Is in chemistry. You use it. See how we did it here. So we did 1,000 gram divided by 1,000 gram. Then this is 12 gram. Then this is 1 gram. 1,000 gram. Then this is 1 kg. Do it on your own, you'll see how we got it. Then the average force. So impulse momentum theory to estimate the average force. So this is the impulse momentum theory where we did Ft equals to mv. That's the impulse momentum theory. So impulse is equals to momentum. You need to know that. A golf ball with mass 5.0 times 10 raised to power 2 kg is struck with a club. The force on the ball varies from 0 when contact is made up to some maximum value when the ball is maximally deformed, and then back to 0 when the ball leaves the club. Assume the ball leaves the club face with a velocity of 44 meters per second. Take s, displacement, or say distance, to be equal to 6 meters. Find the magnitude of the impulse due to the collision. Estimate the duration of the collision and the average force acting on the ball. Use the impulse momentum theorem to estimate the average force exerted during an impact. Alright, so to find the magnitude of the momentum, we'll simply write out the things we are given. We are given that mass is equals to 5.0 times 10 raised to power 2 kg. Then, what else? We are given velocity to be equals to 44 meters per second. We are given displacement s to be 6 meters. So we don't have force, we don't have any other thing, we don't have time, and they say we should find momentum, impulse. So to find impulse, you remember that impulse is equals to change in momentum, and momentum is mass times velocity. So we just do 5.0 times 10 raised to power 2 times 44, which is equals to, let's do it, 5.0 times 100 times 44, which is 22 times 10 raised to power 3 Newton seconds. Or you see, another unit for this is kilogram meter. That is from this, mass is kilogram, velocity is meter per second. So another unit you can use for it. So whichever one, that's the impulse. Now they said we've gotten the impulse. They said we should estimate the duration of the collision. So to estimate the duration of the collision, we need to remember that impulse is equals to force times 10 times time, and is equals to change in momentum. So we need to ask ourselves, this time we're not given, force we're not given. We can't be looking for two things at the same time. So we need to remember that there is a law in kinematics which says that v square is equals to u square plus 2as. So I've told you, always pay attention to these formulas, these two formulas. I told you when I started that these two formulas, anytime you are not given time, use this to find the acceleration, then use this to find the time. See how we are going to do it. So we now do v that we are given. They said when the ball leaves the club, assume the ball leaves with a face. So the v itself is 44. Whenever you remember kinematics, if it leaves, if something leaves with a velocity, that velocity is the final velocity. That means it's starting with an initial velocity 0. So 0 plus, and this is square, plus 2a, then the s is given to us to be 6 times 6. So you can see that 2 times 6 is 12. So you have 12a equals to 44 square, and 44 times 44 is 1936 equals to 12a. Divide both sides by 12. So a is equals to, so 1936 divided by 12. So a is equals to 161 meter per second square. So to get time now, we do kinematics first equation. V is equals to u plus at. V is 44 equals to 0 plus 161 t. So 44 equals to 161 t. Divide both sides by t. That is, sorry, divide both sides by the coefficient of t, because it's t we are looking for, 161, 161. So T will be equals to 44 divided by 161, which is 0.273 seconds. So we'll go back into this equation. So we've gotten the duration. Remember, the second question asks us estimate the duration of the collision and the average force acting on the ball. So the average force acting on the ball. Average force acting on the ball is the same thing as saying, okay, so they said use impulse momentum theory to estimate the average force exerted during an impact. So they want us to explain this, and it's the same thing we are going to use to do this now. So we'll simply do Ft. This is impulse momentum theory. Impulse is force, product of force and time. It equals to change in momentum. So I will simply say F here. Then time is 0.273 equals to momentum. Sorry, remember that the mass is 5.0 times 10 raised to the power 2 times 44. So we've gotten it to be 22,000. So 22,000, or you say 22 times 10 raised to the power 3, which is 22,000. So if we divide both sides now by the coefficient of force, which is 0.273, so you now have 22,000 divided by 0.273. So you have F is equals to 80.586. Sorry, 80. Yes, 80,000. What are you doing? Let's be sure. So we have 80,586 Newton. So this is what we have. So answering this question, use the impulse momentum theory to estimate the average force exerted during an impact. Is simply knowing that Ft is equals to change in mv. So divide both sides by t, and both sides by t. So F is equals to mv over t, average force. All right. So using the principle, I will allow you solve the third one for me. My students, once I say solve the third one, they will say, oh, no, sir. So, no, sir, solve it, sir. So look at the question we just finished. So you pause it. Then, this is the one you're solving for me. In a crash test, a car of mass 1.50 times 10 raised to the power 3 kg collides with a wall and rebounds. Full stop. The initial and final velocities of the car are, or I will just solve it. But you can try it. Pause the video and solve it. The initial and final velocities of the car are u equals to 15.0 and v equals to 2.60 respectively. If the collision lasts for 0.150 seconds, find the impulse delivered to the car due to the collision, the size and direction of the average force exerted on the car. So let's be fast about that one. So to solve this, I will check what I'm giving. I'm giving mass. I'm giving mass to be 1.50. So mass equals to 1.50 times 10 raised to the power 3 kg. Initial and final velocity. U equals to 15 meter per second. V equals to 2.6 meter per second. T equals to 0.150 seconds. Now they're asking me to find impulse and then find size and direction. Force has for size and direction, so no problem. It's a vector quantity. So they're telling me to find average force. So I'm finding impulse and I'm finding average force. So impulse equals to mv. And remember that in this case where velocity, I have final and initial velocity, you remember that momentum is also, this v that is here is a product of change in velocity. So momentum can be mass times change in velocity. And remember, I told you linear velocity deals with one mass. Once you start dealing with more than one mass, it's no longer linear momentum but conservation of momentum. So this will be the same thing as saying v minus u m. So that I will now do 2.6 minus 15 m. And if I do 2.6 minus 15, you have minus 12.4. So times 1.5 times 10 raised to power 3. So 1.5 times 1000 is 15. So 15 times negative 12.4 is negative 18,600. And its impulse, which is Newton seconds, or you say minus 18,600 kilogram meter per second. So this is the impulse. So it's the same thing. I just used the units. This one represents that it's first times time, but the major unit is this one. So to get the average force now, notice that they gave us time. Everything is simple. So to get the average force, I'll simply say Ft is equals to change in mv. Sometimes putting this change in mv makes it look as if even the momentum will change. No, it's better you put it this way: m change in velocity. So remember, this can be the sentence. Since we are looking for f, divide both sides by 18. So I have f equals to, I've gotten mass and velocity here to be minus 18,600. So minus 18,600 all over the time. The time given to me is 0.150. 0.150. So 18,600 minus 18,600 divided by 0.150. So F, the force is going to be minus 124,000. So that means that the force they are talking about here, the average force here is like average, is more like an opposing force, a resistive force. So you need to know it. Anytime your force is negative, it means it's a resistive force. So that's my answer, and it's going to be in Newton. Force is in Newton. So that's for it. So in our next class, we'll start from conservation of momentum. Answer these questions. As you can see, these are questions for you. You can pause it and try your hand on it. For those of you that always say post question, subscribe.